This is how to calculate work. We define work as a transfer of energy, and I'll get back to that in just a sec here. Um, but the formula for it is that it's basically a force times a distance. So if I were to drag a box like this with a force, let's say I exerted 12 newtons of force on this, right? And I dragged it 4 meters, right? Let's say 4.0 meters, right? Okay, the work would just be 12 newtons, right, times 4 meters, which would be 48 Newton meters, right? That's also the same. You can just say 48 joules. Or, if you really get to know, physics, you can just say 48 J like that, right? A Newton meter, or a joule, right, it's a kilogram. A Newton is a kilogram meter per second squared, right? Because F equals MA. And so a Newton meter would just be a kilogram meter squared per second squared, right? So that's, if you ever wanted to know what all the units are that are in a joule, that's them, right? Okay. And so that's the basic idea. And most of the time, this is what you're going to do. Okay. Now, sometimes the force is not in the same direction that you're pulling it, right? They're not parallel to each other. Here, the 4 meters was to the right and the 12 newtons was to the right. But if it's ever not in the same direction, then we've got to use the cosine of the angle between them. Okay. And this next animation here, I think I won PowerPoint of the Year in 2003 for this. Look at this. So we're dragging a sled to the right, but we're dragging it with a rope that makes an angle with the ground. So the sled moves this way, but the force is that way. Now, if you look at this, there's two components here, one parallel to the direction that we moved and one perpendicular. Since it didn't move up, this component didn't do any work. This one did all the work. That side is F cos theta because that's, of course, the adjacent side. There's the opposite side. There's a hypotenuse, right? So this is F cos theta. It's only this component that does work, and that's why it's Fs cos theta. Okay. Now, when you get to college, they're going to write the same formula this way. They're going to go work equals F dot, right, S, right? The dot there actually means the vector dot product, which is Fs cos theta, okay? These are both vectors. Force and displacement both have a direction to them, right? But work doesn't, so a dot product actually creates something that doesn't have a direction. Okay, just remember that when you get to college, you'll use that. Okay, so that's all there is. There's some tricky bits here. Okay, well, this first one is not too tricky, right? Most of the time, the force and the displacement are in the same direction, so you push it that way, and it moves that way. Well, that's simple. There's 0 degrees between them. Cosine of 0 is 1. So most of the time, this thing goes out of there, and it's just F times S, right? Okay. Now, sometimes they're actually in opposite directions, right? Well, if they're in opposite directions, they're 180 degrees apart, and so cosine of 180 is actually -1, which means that you did negative work, right? And I'll talk about this in class because it's something I can show pretty quickly by just lifting something, right? But if I take some object like this and I lift it, okay, I exert a force upward on it and it displaces itself upward. Well, it started here and it ends here, right? Doesn't it? Started here, ends right there. Okay, so I've actually done positive work. If that's F and that's S, F and S, this is +1, right? I've done positive work on this thing, lifting it up, right? It now has energy. It's now up in the air. It's got potential energy, right? On the other hand, if I lower the thing at a constant speed, that is, I don't let it drop, but I lower it at constant speed, which means I exert a force up on it equal to its weight, right? And then it displaces itself downward. Well, the angle between up and down is 180 degrees, right? And so I've actually done negative work. And so what it is that I haven't given energy to the mass. The mass has actually given energy to me, or I've taken energy away from the mass, right? And that's really all you need to know to calculate work. Okay, I'll do some examples, but I'll do those in a different video.